fun camera, but it's not a game camera. So, well, welcome everyone. And thank you so much for gathering today to witness and to celebrate Molly Lee's thesis defense. And title of her thesis project for the Wildland master's degree is Assessing Seed Density of Blue Wildrye Limus glaucus for Restoring Native Flora in Burn Pile Scars in Northern California. We'll proceed. Molly will give us a presentation, and then there'll be a little time for questions and answers from the room. And then I think we'll maybe adjourn, and the thesis committee, such as it is, we'll have deliberations, and then we'll take it from there.
Right.
So Molly, it's all yours.
Awesome, thank you, Don. So I'm just gonna reiterate what he said. I'm Molly Lee, a Wildland management student, and this is my defense presentation. So a little bit about me, I kind of started my interest in fire back in 2017 when my hometown of Santa Rosa got hit by a big fire. So that led me during my undergrad to do a study looking at different periods of post-fire in Annandale State Park by my house, just looking at the regrowth. It wasn't super in-depth, but it was something and it got me interested. So then when I came up here, and there's a great fire program up here, I got more into it, and I also saw, like Mitch, you put seeds in piles, and even Paul put seeds in piles, but has it ever been quantified or recorded? So that led me to this presentation today. Again, assessing seed density of blue Wildrye Limus glaucus for restoring native flora in burn pile scars in Northern California. These are the topics that will be covered in today's presentation. I'm going to start with the introduction, move through these topics, and finish with limitations and further studies that could be done. Just a brief introduction, this thesis looks at the addition of blue Wildrye seeds into burn scars, and specifically burn pile scars. I did 4 different densities, a control, which was no seeds, a 0.5 gram of seeds, 1 gram, and 1.5 grams of seeds. The piles were allowed to then just grow on their own over 5 months, and then the above ground biomass was then collected, which is all greenery above the soil. So here are some problems. Using fire as a management tool has increased in the past couple of years. This is not really a problem, it's actually really cool. However, there is not a whole lot of research done on the effects and how to restore post-fire. Burn scars, pile burn scars more specifically, since it's more intense heat on a focused area of the soil, can leave the soil barren of vegetation for a couple years post-fire if nothing is done. That lag time can then allow invasives to come because there's no competition. So the addition of native seeds might be able to address this. And lastly, there is a big gap in research in this area. During my studies, I did a deep dive and tried to find all literature out there, and I found that there was not a lot done in California and on scales that can be reproduced by landowners, property owners, and homeowners on smaller scales. The objectives of this study was to support restoration and burn scars by the addition of perennial grass seeds that are already native to this area. Evaluate different densities of seeds in these burn scars to see if there is one that is optimal compared to the others. And this can also help create a guide and some data that people can use if they're managing big properties, small properties, just to get an idea of where to start with their restoration in post-fire. Hypothesized that the 3 different seed densities, a 0.5 gram, 1 gram, and 1.5 gram, were going to produce different biomass than the control, which was nothing at all. So first, pile burning. Pile burning is different than broadcast burning or prescribed burns. Prescribed burns and broadcast burning is like these pictures here, where you send more low-intensity fire across a larger landscape to clean up unwanted fuel and debris. And since it moves quickly, it does not impact the soil as much. And with pile burning, it's collecting cut and thin material and burning it into a pile that is concentrated on a specific area of soil, which can have adverse effects to the soil. However, the fire does not move, so it is easier easier to manage, and you don't need as many resources as you do if you were to do a broadcast burn. Fire and flora, which is plants, have coexisted for a long time, over 400 million years. So the first fire being recorded around the same time the first terrestrial plants were recorded. So over these years, they have learned to adapt with each other. And some of these characteristics are survival characteristics, and some support germination post-fire. So survival would be like resprouting of the Quercus species after it is burned. And Pinus sibinia often has their serotinous cones, which needs fire to open up and start the germination process. And a lot of these adaptations we do see today. However, during that lag of time where people were suppressing all fire around, it may have caused some of these plants to lose their adaptations because they weren't needing them. And now with these big mega fires that come through, they aren't quite as ready for the increased fire regimes that we see now with the anthropogenic impacts. Soil effects. Fire does affect the soil, especially for bile burning because it is concentrated. The soil, it can affect the soil's chemical and physical properties. So physically, it can get rid of all the vegetation and even burn to make the soil a little hydrophobic, which can be problematic, as well lead to erosion because there's not those root systems in there all the time that can support and hold the ground in place. Chemically, it affects the soil by increasing the pH levels and decreasing the carbon and nitrogen levels. Even with the moisture loss, it can lead to root death and even seed mortality. So this brings the addition of seeds. During the time after fire, there is a lack of seeds and vegetation on the ground. The addition of native seeds helps combat the possibility of invasive annual species that would be able to come back quicker in that exposed area. There's a couple studies done that I found when doing this research that found after a fire, there was more invasive species seeds in the burn scars when compared to outside. And then when using active restoration efforts of seeding in these piles, there was a 70% increase in native flora when they added native seeds to these piles. And then the addition of Elymus glaucus. So I picked this seed because it is a generalist. It can grow in many different types of soils, which is good after a burn. And there was a study done out of the UC Davis that looked at different populations of Elymus glaucus, coastal and more central. And the central populations, it found that they actually do way better against drought because they have a way deeper root system than the others. So it makes it ideal for soils that are burned. They can maybe get down deeper and get to water that other species might not be able to get to. And then there was another study done that looked at germination of Elymus glaucus when exposed to smoke. And it found that they actually have an increased germination after exposure to smoke, suggesting it could benefit from fire after. Methodology. So the sample population is Elymus glaucus at Beezer, the Big Chico Creek Ecological Reserve. My study sites are here on this map. This is a map of the whole reserve. Each of these points is a different site. These sites are all on west-facing aspects and under Quercus callagii black oak canopy, and they are as similar as possible as I could get. The different treatments I have here are the control, which is no seeds, a 0.5 gram of seeds, 1 gram of seeds, and 1.5 grams of seeds. And these were all randomly assigned to the piles. I collected all of the above ground biomass, which is all greenery above the soil. That was then dried and weighed. And I did all of my statistics in RStudio. I ran an ANOVA test and then also a Tukey multiple comparisons test. A little more about the project timeline. The seeds were collected in August of 2023. They were stripped by hand from a place on Beezer at the headquarters. I kind of haphazardly picked which seeds to collect. And then in October, the piles were constructed. So these piles were constructed on a scale that could be applicable to homeowners, landowners, and property managers so I did them 1.5 meters in height, 1.5 meters in width. On CAL FIRE's website, that's roughly like 4 feet by 4 feet is appropriate for homeowners. And in Butte County, outside of fire season, you do no longer need a permit. So this is applicable for anyone who wants to. So I started with fine small fuels at the heart of the pile. This is anything 1 hour fuels and less, which is roughly 1 centimeter. And then I started by layering larger fuels, like 1 hour to 10 hour fuels on top of that, which is anything less than 2.5 centimeters. And then once the piles reached 1 meter in height, a piece of forestry paper was placed on top to keep the piles dry in case there was rain between when the piles were burnt and built and then burnt, and then finished with larger fuels on top. No fuels greater than 100-hour fuels, which is roughly 8 centimeters in diameter, were placed because these piles were then led to burn completely out on their own with no addition of fuel, like extra fuels. The piles were then all burned by November 27th, which gave them roughly 2 weeks to dry and settle before they were burned. They were burned using pitchwood because I did not want to add any torch mixture to the piles because it could affect the soil. And they were allowed to burn out completely by themselves. And exactly 1 year ago today, they were all seated by hand by me in the center of the pile in a 1/2 meter by 1/2 meter quadrant. And the seeds were put in after 90 to 95% of the white ash was scraped away to make sure they had a better chance of germination. And then in May of 2024, all of the above ground biomass was collected. So what does this mean? So I have 3 different results that I looked at. I looked at the biomass, which is the dry weight divided by the fresh weight multiplied by 100. And these are the values I got from the 2P test. So I ran an ANOVA first, which just shows which means were different from, if there was a significant difference. But it didn't tell you which means were significantly different from one another. So I ran a 2P test. And here with the P values of less than 0.01, it shows that all of the different densities, a 1/2 meter or 1/2 gram, 1 gram, and 1.5 grams was significantly different from the control, which was nothing at all. And then I looked at the mean dry weight. So this one is a little interesting because you can see that treatment 3 and treatment 4 are significantly different from the control. However, treatment 1 isn't significantly different. I think this is due to a small sample size. If I had more replicates, we would have had better data because practically 50 grams of biomass or of mass is significantly different from no mass at all when you're planting seeds. And lastly, I looked at the mean dry mass divided by individuals in that. And again, you can see that from the control, all 3 of the densities were different, significantly different. So what does this mean? It means that the addition of native seeds, of perennial grass seeds, had a positive effect on all of the plots where they grew grass compared to the controls which had nothing at all. However, it can also be suggested that it is not necessary to seed more than a 1/2 gram per quarter meter squared because they are always yielding around the same biomass and mass because they're not significantly different from one another statistically. And this can save landowners, homeowners, and property managers time, seed, and money, knowing they don't need to seed more than a 1/2 meter or a 1/2 gram per quarter meter squared or 2 grams per meter squared. The limitations in further research. So there was a short timeline for this study. The grasses were not allowed to go to seed and drop their seeds, which would have like more guaranteed an establishment of this population, which turned out it didn't really matter anyways. But if I could, I would have allowed them to go and drop their seeds. And then you could also monitor the spread out of the initial center of the pile to see if they really do establish a population. Grazing on 3 out of the 18 piles that produced grass, most likely by a black-tailed deer or other consumers. To combat this in future studies, I would suggest putting up maybe a small fence around to help keep them out. But it also does show that, Ilma's Bacchus provides food for the animals that live on the reserve. To go with future research, I suggest trying the same methodology, but maybe trying a different species. So we could try Bromus carnatus, California brome, which is also found on the reserve, another native plant that is here. Or trying different canopy covers. Black oaks are deciduous oaks, so they drop their leaves. You could try under maybe live oaks, but I probably won't be too positive. And another suggestion is to try lower densities of seeds. We found that over a half gram, all of the biomass seems roughly the same. So maybe at lower densities, they might show a drop in production if you get too low and it's not enough. So with that, there's still a lot of research that can be done. I hope this study can serve as a foundation for further research on seed banks and what to do in restoring cattle burns post-fire. And that is my presentation. So thank you guys so much. Any questions? Yes.
So can you go back to the tables with the biomass?
Yes.
Sorry, I probably could ask it without actually looking at the tables.
Yeah.
In your mean dry biomass tables where the lowest treatment density was not significantly different from the control, was there a pretty significant variation in biomass produced? Do you think that even though like the mean dry biomass and or the dry weight per individual and those metrics were the same, adding more seeds, even though in general for the biomass didn't really make a huge difference, adding a little extra seeds to just reduce the chance of stochasticity and variation success kind of over establishes the plants to help prevent complete failures in plots, and that could be something that might make it a little worth going above the seeding densities that you found were working all kind of equally.
Okay, so seeding a little bit
like
more?
seeding overkill just to prevent like that wide variety in
because there was densities or there was dry masses that were like 130 grams and then others that were like 13. So that could also be due to the grazing because it definitely affects the overall mean mass. So that is
grazing still is just something that could cause a restoration project to fail. So adding more seeds could help
benefit that as well.
To help prevent the effects of things like grazing. Even though in like a perfect condition where you have exclusions, you might not need that. Seeding a little higher than necessary might be able to be one way to ensure against things like grazing and other outside factors that can affect establishment.
Definitely, that makes sense. Yes.
What is the viability of the seed in this, in the seed bank? Like, how long would that seed have the ability
to germinate? It is a perennial grass, so it should be able to die off and come back each year, following year.
But I'm just wondering, like, for example, like overseeding, right? Like the seeds that might not fully germinate because maybe they're crowded out. Do they have the possibility to germinate in later years?
Like be dormant and then come back if there is a gap? I'm not sure. I did not look into that. But that is definitely something.
I can't remember off the top of my head. I think it's not super long for grasses, but I could.
I mean, that'd be an interesting thing to look at too, because even if, an overseeding, if those seeds were viable for multiple years, could also be worth it because of a disturbance.
Then they have a second chance. Definitely.
Did you look into at all how the size, I'm not sure if there is research available on it, but the size of these Elymus glaucus individuals increases as they increase in maturity over successive seasons, and if you might start getting more competitive effects
Further
after
on.
3, 4, 5, 10 years of those plants being.
I did not look into that, but it's something I can add and research further and see if
Yeah, not
in the long term.
necessarily something you need to add to
Mhm.
thesis, just something that I could see in like
In a more
longer-term
long-term study,
where the super high density things could have
start to compete with each other.
significant interest-specific competition after longer terms as the plants increase in size.
Yeah.
The other thing I was just kind of interested in was you talked about I'm sure I remember reading it in your discussion, but or not discussion, the literature review, but the paper that you were referencing on the smoke stimulating germination of the Elymus glaucus seeds. Do you remember if they found a specific pathway or chemical?
They did smoke water, is how they studied it, and they found that the
Butanaloids?
Yeah.
was
What is the, sorry, the compound again?
Butanaloids.
Yeah.
Butanolides?
Yes. I just was reading it.
Yeah.
It's in the thesis.
It's in the paper, yeah.
It's in there.
It's specific ones.
Do you know if that compound that does stimulate the seeds stays in the ash and charcoal in the piles post fire, and if seeding into those piles could be actually better for success rates than seeding into, say, an area where you scrape topsoil or apply herbicide where you don't have potentially some of that compound still residing in the soil.
I am not sure. So they use smoke water, which is kind of more artificial.
It just made an interesting further study to look into if actually seeding blue Wildrye into piles
Seeing how
that
long
haven't
it
burned
stays.
or actually provide more germination, more success than seeding into other conditions because of that. I know, like both Paul and I told you, just based on our observational, what we've seen doing this in the field over multiple years, that scraping the ash really increases the germination results. Do you happen to find any literature that would support why that is? Because I've never seen anything on that, but just looking at it,
I did
the
not.
heavy white ash never seems to work well.
Yeah.
I'd just be interested if you know anything.
Yes.
Yeah, so you talk about this applying for homeowners and primaries. A lot of homeowners don't usually have as large of an area to create their pile burns in.
That's true.
Reuse the same burn scars. How might this be able to apply for, say, a site that had 2 burn piles in it, in that soil there?
It could just be a starting point of measuring their piles and knowing to start. That's why it would be interesting to see this over long term, because then you can know if I start in these piles, it'll eventually expand outside of these piles and start to establish a better population on that area. So I'm not exactly sure how it would do, but it would be definitely interesting to study that and see if they do reach outside of the center of the piles. Did that answer your question? Kind of. Yes.
A quick question and then a little bit more thinking question. The quick one is, did you stake or flag these so someone could come back to your particular sites?
They're on a map, so they are on Avenza, and I believe some people here have that Avenza, but
So you can use the map
you can use the map to find where each of the piles are.
That's how someone could follow.
Continue this, especially post
Post-wildfire.
wildfire, which is a different type of fire altogether. Yeah.
We did discuss actually trying to do that, though, because of the manipulation to get this particular data. We said if we did, it would just be a different study that we would do.
Oh, yeah. Because
It kind of skews the data by removing all of the biomass before it technically
could drop.
Yeah. So that's why we have discussed kind of how we would do this in the future.
And then the other thinking question is that in the introduction, did I hear you say or suggest that fire suppression, long-term fire suppression, may have affected the fire or the fire adaptation of certain species?
Mm-hmm.
That means that's an evolutionary response in the time frame of decades?
Yeah, centuries, yeah.
Well, maybe fire suppression is just in the last century.
Mm-hmm.
And I'm just curious about whether species can modify their adaptation for fire.
Yeah. And that's one of the things is because as humans make more of an impact on this, the fire regime is different than what it would have been in the past. So can they adapt at the rate of how we are having these fires? It's definitely something
So
interesting.
that's a question you're asking around to the supposition you're making.
Yeah.
Okay.
Yeah. Yes.
And then related to that, once these are established, the Lemus glaucus plants, perennial plants with a deep root system, how well do they respond to fire? Do they have a robust response to being burned?
Yeah, I'm not sure again.
Observationally, they do quite well after being burned.
They can come back.
Yes.
So, yeah.
Again, heat intensity and like if there's a log line on them that burns for a day, that probably would not come back until below ground root crown. But if there's enough soil to insulate them over the root crown based on how fast the fire moves through the area, usually it does quite well.
They can come in. And I wonder what the proportion of the below ground biomass of the root system is compared to the above ground biomass of grass, perennial grasses.
Mm-hmm.
Yes,
Yeah.
that's always a fun project to
Yeah. You
wash a
could
bunch of roots.
do the whole biomass, but we said for this one it's easier just to do above ground.
Yeah, so I have, Kristen texted me a question, because she didn't know if you could get it in, or did she might have.
She might have, I didn't look at it.
That's right.
It's fine. She didn't know if she'd be able to get
No,
it
we
in.
want to hear you ask.
And so we were kind of talking about the above ground biomass, but she wanted you to clarify, that you just collected above ground biomass, and what are your thoughts for those plants potentially resprouting after the park fire?
So I did collect just above ground, everything above the soil. I hope that they will resprout. I hope that it was enough time before fire that they were able to establish. And I mean, sponge grasses get burned and they can come back. So I hope that they can resprout and come back after the fire.
Yeah, it's really interesting anecdotally, like you can see your pile of scars in the areas that are, like, people can see the line.
You can see this,
Yeah.
because we scraped away all the bare,
Yeah.
straight down to the soil.
And you can see like where the charcoal is too.
And the way we were doing, we seen.
I haven't gotten anything about that, but it was when the crews were working in your site that was below the barn, like that area. But they haven't been back there.
I do think anecdotally, or more coincidentally, not anecdotally, the areas that you chose for your studies were some of the highest intensity and hardest hit areas of the reserve. So
Is it because it came across and up that
it's just
space?
a lot of the areas that we did our work were areas with a lot of fuel loading to build piles, and a lot of area cleared out to reduce that intensity. So some of those areas burned very, very hot. I'm not sure if there was anything to come back, but maybe
We'll see.
Yeah. All right. Any other questions?
Good.
You want to?
Okay. Two questions. One is, you mentioned earlier that local genotypes, local populations of this species will have certain local adaptation traits, such as the Central Valley having longer roots. When you mentioned that local population specifically, did you do it because that's the genotype that we have on the beaster, or do you not know?
I don't know specifically. I mentioned that because it's a similar arid ecosystem here, so I don't know for sure, but I was assuming they were going to be roughly the same, adapting the same way to the climate that is here.
where the exact population they were talking about was located in that study?
I want to say like up farther north, like more in Reading.
Yeah, that's what I think I remember.
I think it was Reading.
Yeah, it's, Lemus glaucus is also found throughout most of the western United States, so it's a
And
very wide ranging, so just kind of.
And that's why it's also used in a lot of restoration.
Second question. So I see you included lower and upper. Do you visualize your data with the box plot?
I did. Yeah, it is in here. Yeah.
It's in there.
It's in there.
I didn't know if it was.
Okay, I just asked because I've noticed with your uppers and lowers, it seems you have a bit of spread, and there's some spread that's collected. So it seems like some of them are grouped, and their spread is roughly the same, but then others are grouped down below in their spread. I'm just asking because I'd be curious to see what the variance is and whether their what their distributions look like.
Yeah.
That's.
You did a normal probability plot, no?
I have,
Am I right?
I believe so.
Yeah, I think there was an examination of that, I think, in there.
In the appendix, I believe.
Yeah, in the
Yeah.
appendix. Yeah,
It'd be in
yeah.
the
I don't know
very-
if that's,
It's not in the main text, it would be at
Yeah,
the end with all the R
okay.
code.
And I'm sorry, I might not have caught this in here, but do you, when you're talking about the, I guess the implications of this for landowners, do you consider areas that had high fuel loadings in wildfires, like large down logs that burn, things like that, that also have that long residency time that cook the soil of potential?
I was looking more at if they were to do burn piles and so composition of the piles and what materials are in there definitely impact the soil differently. So I was mostly looking at if they were to just hand thin something by themselves and build a pile.
I'm just thinking that it'd be an interesting study post wildfire, but likely the soil impact from a large pile burn, getting burned down, and a log burning over an extended period of time in a wildfire has similar soil impacts.
Because of the time it's sitting on the soil.
The time that it's in the soil and the high intensity of the fire.
Yeah.
So this could be, this could be replicated not only on pile burns at the homeowner scale, but likely when you got a limited amount of seed within a wildfire footprint, finding that areas that
more
has a higher
severity. Yeah.
Were some of your papers you referenced in your literature review deal with wildfire and high intensity fire versus pile burn? I can't remember.
No, they were mostly pile burning. But some of them, like a lot of the studies out there aren't on the same scale. Some of them are like with the Forest Service, so they do big piles, so.
Big machine piles.
Yeah, some like full trees. So that it is important to know that your composition of your piles and what is in the piles is gonna make a difference on the soil.
It sounds like there's a few things in here that you might consider, just at the very, very end here, just putting into that for future research category of like, this could be replicated in wildfire footprints, areas that had high fuel loading or 1,000-hour plus fuels. And then some of the other questions around like the longevity of looking at it, and how it spreads. All of those things I think are just a few sentences in that future research section.
Do you think the scale of the piles that you used versus some of the piles that you referenced, the larger machine piles, kind of provides kind of a middle ground between removing competition and adding possibly beneficial chemicals such as the smoke compounds to the pile, but also not damaging the soil so much that some of the fungal components in the soil are completely gone or can't easily recolonize like a big pile the size of this room might have? And do you think that would be something interesting to look at as like the success of these studies would be changed in larger size piles?
I think so, definitely.
Quick question, how expensive is the seed? Is there a real cost saving from half a gram and a gram per?
That is
You
a
collect
good
it by
question.
hand?
Yeah, actually,
It's not
I didn't-
something commercially.
Yeah, we
we're
collect
not-
it all by hand.
But
So I guess
Can you purchase?
but you can buy commercially.
You can buy commercially. It's fairly expensive. Blue Wildrye is one of the cheaper seeds you can get, but compared to like buying seeds of any other crop, native seed sources are one, very expensive, and two, very difficult to come by. So the amount that you need it's a large problem in the restoration industry in California of like seed sourcing.
So tenths of a gram do matter.
Yeah.
And in scale, it's 50% of your seed amount. If you're doing this 1,000 times over.
Any other questions?
I guess a couple of related ones. Where else might you present the work, and then where might you consider publishing, maybe a scientific note?
It could be interesting to take this to the Plant Society at the conference again at Chico.
I know of certain poster abstract deadlines that are in about a little over a week.
Okay.
That could be,
Yeah.
just saying,
Uh-huh.
December 15th,
Okay.
or certain local symposia.
Yeah. So that could
So
But it's secret, Mitch won't say it.
Yeah.
That's a really friendly venue,
Mhm.
and you've already done all this work.
Yeah.
And you had a poster, not in the poster, but describing your research plans
Yeah.
on our booth last year.
Yeah, that's true.
To update the poster.
Mhm. As far as journals, I'm not sure exactly a specific journal, but an ecology-based journal.
Yeah, I don't know, people have
Yeah.
ideas. I mean, the literature that you use
Huh?
is one source.
Is there a draft
Where people
map?
publish.
Well, it'd be nice to add some research literature to the, everybody's citing very similar journal articles. It'd be really nice to have some research.
Yeah.
That's on me. Yeah, I gotta get some of them to Gary or somebody. But yeah, think along those lines, to reach the outside world.
Yeah.
Sure.
You have a question?
Hard question.
Hard questions.
Yes.
How fresh is fresh for this when you harvest it for weighing?
Mhm.
And then how dry is dry? How long does it take? How to dry it?
So fresh is, I went out there, I collected it, and I took a scale with me out into the field and weighed them as soon as I cut them. So pretty within like 5-10 minutes of cutting and weighing. And then dry, I took it back to headquarters in an incubator and it was dried for 48 hours at 60 degrees Celsius. And then an additional 24 hours until it reached a consistent weight.
Pretty standardized methodologies.
Any other questions?
Had these plants produced seed heads?
They were getting close.
Wow.
So they started, and I have pictures of them. They were getting close, and they were starting to even. You can see they were reducing some of their energy in the leaves. The leaves started to wilt a little bit, so I think they were getting ready to.
Generally, when perennial grasses produce seeds in their first year, they're doing pretty well. So
Okay.
a lot of times it'll take a year or two to actually get to seed production maturity.
Any other
Questions or comments?
What was the like atmospheric conditions the year that you did this? Was this a normal, above average? Any notable rainfall conditions?
There wasn't, between the times that the piles are burned and that we seeded, I did seed on a rainy day. So there was some rain, but I don't think it was above average. I do have in the appendices all of the weather data. Unfortunately, not from the station at Thesis, but from a one in Forest Ranch.
Wow.
Thank you so much for coming out. And you guys had some great questions that will definitely be helpful.
Well, at this point, I guess the public can be excused, and the thesis committee, such as it is, can remain. It's Mitch and I.
Yes.
Is there anything? Oh wait.
It's
Have a nice day.
the door.
See ya.
Thanks for coming.
Nice seeing you guys.
Okay, I